and good morning to those of you in the central and western parts of the U.S. We are going to be stepping into a training webinar that's in preparation for an upcoming DOE implant training that will be held at 3M's Cordova, Illinois facility here in about a week and a half. Right now you have Tom Wenning speaking. I am with Oak Ridge National Laboratory, and we support DOE through the Better Plants program. And just as it happens, the Better Plants program has wonderful offerings such as in-plant trainings, where we get an opportunity to go out into facilities and train people on how to do an assessment and also perform an assessment at the same time. So with that, we're going to step into just kind of a quick overview, and then we're going to get into the meat of the matter today. And I'm going to pass the baton off to Riyaz here in a little bit. But real quick, before we get into the STEAM stuff, the fun stuff, the STEAM stuff, right? I have to go through some of the high-level things. What's the Better Plants program? I see we have a number of attendees here, and it looks like most of you are with companies that are already Better Plants partners, which is excellent. A couple of you, it looks like, have been repeat offenders and have held a couple of these implant trainings, which is a competitive process. And it looks like some of you see the value. Others, it looks like you have not quite applied for some of these implant trainings, but maybe after seeing today's webinar, you may have some interest in applying for one in a future round. So again, I said this implant training, it's a part of the DOE's Better Plants program. The Better Plants program, as most of you already know, since your companies are involved, it's a voluntary program where your company has made a voluntary pledge to reduce your energy intensity by roughly 25% over 10 years. There's two levels, a program level and a challenge level. 3M is one of these wonderful companies that have actually stepped up to the challenge level, whereas they are a bit more transparent with their activities and their data. And really, there's only a handful of those challenge partners that are out there, but there's some excellent companies in that realm. So for those of you listening that are not part of the Better Plants program, look into it. If you're already a partner in the Better Plants program, look into the challenge program. It's a good opportunity. So with that, the implant trainings, as I mentioned, it's an opportunity to train people how to do an energy assessment. And in this case, here in a week and a half, we're going to be having Riyaz come into a 3M facility, and he's going to be doing an assessment. This is a hardcore assessment. Riyaz is one of these guys. He does assessments all over the world, and he's going to be taking a group of people with him and training them how to do it as well. So training people on the fundamentals and the basics of how to identify opportunities, how to analyze opportunities, quantify them, and then hopefully towards the end we'll learn how to wrap some of that stuff to bring them through to implementation. So I'm going to keep just moving here. There's a lot of benefits of these implant trainings. For those of you that have already applied and have kept reapplying for implant trainings, I think you've found the value, and hopefully you'll see that for those of you that are going to be showing up here in a week and a half. For those that have not, if you're with a company that has not had an implant training, I would suggest or recommend looking into it. There's a lot of benefits here. There's been quite a bit of preparation that has already gone into this, so I want to recognize some of the guys at the plant. Jim, Rich, and Mark have been an excellent asset here. So is Deb and Steve at the corporate level, all with 3M. There's been, like I said, a lot of preparation that's gone into this. Hopefully next week or a week and a half from now, we're going to have a really good event. As I mentioned, there's going to be some field training where we're doing the assessment, but there's also going to be some of the classroom training as well. So it'll be a nice mix for those of you that are interested. Our agenda is really shaping up to look like a 3-day event where we're kicking off on a Tuesday, and we're going to wrap up on a Thursday afternoon. So it's looking to be one of our better implant trainings. So for those of you that are showing up, hopefully you're getting excited. For those of you that are kind of on the fence or maybe interested in attending, this should be a really good, strong event, and I would suggest contacting either your technical account manager or myself if you may be interested. So with that, we do have a couple spots that are still open. So for those of you from other companies, this is open to other companies on a case-by-case basis, obviously. But if you're interested, please contact me. Again, I'm Tom. Or you can contact one of the individuals at the plant, Jim Rutenbeck, and I flash his information up there. So with that, I'm going to do a quick highlight on Riyaz. Riyaz, I've worked with him quite a bit. He has a storied history, but he's truly one of these guys that is an industrial expert in the steam system. He does a lot of other things as well. He's salt-of-the-earth type of engineer, can go really deep, but at the same time, he can step back, look at the big picture, talk high level to the management types as well. Riyaz, I've traveled around the world with him. He is, in my view, one of the best in the world when it comes to steam systems. With that, Riyaz, I'm going to try to pass this over to you and let you run through the best practices and the assessment aspects of looking at steam systems. So Riyaz, I just pass it over to you. You should receive the okay, and I see your screen, so you're good to go.
Okay, thank you, Tom, and thanks for the brief introduction. Appreciate all the support and help that you give us. A very, very good afternoon to people on the East Coast. Good morning to people still in the Central Time and other places. Very happy New Year to everyone also. Appreciate you taking the time today to being here on this webinar. It is going to be relatively a fast-paced one because my intention is not to kind of really get into details at this webinar level. We will have lots of time and opportunity to get into details in the in-plant training. So what I'm going to try and do is do a broad brush perspective of the US DOE Steam System Best Practices software tools, which is basically the engine that we end up with in the energy assessment. Again, Tom's already given my introduction, so appreciate that, Tom. I work for a company, Hudson Technologies, but the hat that I'm wearing right now is working for DOE and for 3M in this 3M in-plant training in Cordova, Illinois. Our agenda, I think, is very brief. I think the webcast introduction has already been given by Tom. I want to jump into steam systems. That's kind of the area that I kind of live in. Most of my work is in the area of large industrial facilities, and we'll talk about some of the places where I end up going. I want to give you a brief introduction and kind of try and show you some of the functionalities of the tools to give you an idea of what are the things that we can do, we should be doing, and how can it lead to possibly identification and quantification of potential projects. I do want to leave some time at the end for a question and answer. I would assume that you're more than welcome to probably end in the chat box and type any questions. Tom, if you don't mind keeping a look at that chat box, and periodically if I am at a pause or something like that, either bring my attention to it. If I see something, I'll pick it up also. When we kind of get into energy and we talk about industrial energy and so on and so forth, a lot of times, you know, basic understanding starts off at a high level as what is the place where energy gets used or how it gets used. This is a very old pie chart, but it's still true as we go into industrial systems. When you look at an industrial plant and we look at like within the plant boundaries, you might have a significant portion of energy being used up for making steam. You may have process heating as big pieces. You have a big chunk in motor systems, and then additional things, facilities, so on and so forth. Point here was that understanding at a high level where your focus should be is key. This may be a US national average, but may not necessarily represent what your plant specifically is doing. But that's the first place where we would begin. That's the first place to kind of give us an idea of what should we focus on. Should we hit process heating hard? Should we hit motor systems hard? Should we hit steam hard? So on and so forth. Once you have done that, one of the things you will find, and I'm kind of obviously biased towards steam, I spend a lot of time in heavy steam users. You will have petrochemicals, refining, forest products, manufacturing, assembly plants, food, beverage, so on and so forth. You got steam users, which I would term medium. And again, my large and medium and small kind of has a combination of amount of steam, pressure, distribution levels of steam. Larger steam systems will have multiple headers. Larger steam systems will use much more steam than a medium and a small. Also the operating pressure, steam generation pressure may be a lot higher in some of the large, heavy steam users versus say the medium and the small steam users. Depending on your process application and demand, that's kind of like the three buckets I put most of the industries in. To evaluate a steam system and pushing it further, one's got to take a systems approach. Steam is a system, and you'll probably hear this from me in this webinar for sure, but for those of you who are attending the in-plant training will surely kind of get a true feeling of why I kind of keep it as a system. When we take a systems approach, we really got to understand what the current system conditions are, how the system operates in terms of responding to demand, in terms of seasonality, in terms of production schedules. Where do we have the potential areas where there could be improvements that can happen? Taking these identified areas and analyzing them further for improvements. A lot of times that's kind of like the place where everything stops, because really we don't get into implementation because, oh, we did the assessment, but we don't know what else to do after that point, and the ball gets dropped. But continuing forward to implement these system improvements and then continuing on to monitor this overall performance is kind of like where the overall systems approach falls into place. As I said, a generic steam system in our world consists of four major areas. Generation, which is where steam is generated. It includes everything from the feed water side all the way to heat recovery to steam generation. Once steam is generated, it's got to be distributed. Distribution systems can be very simple, as shown in this figure here, or could be very complex. And we got to kind of understand each plant. Each plant is unique, and each plant will have its own characteristics, its own systems. So you got distribution surely to think about. End use. Why is it that we create steam in the first place? Process heating, power generation, stripping uses, all different kinds. And this kind of is a large area where sometimes are the biggest opportunities that could be found, although that may not be something that you can uncover very easily. Last but not the least, recovery. It is a closed system, which implies once steam has transferred its energy, done its job, it's now condensate. Condensate is distilled water, basically, which is kind of has to be returned back so that it can be used to create the steam, and the cycle is completed. Hence, a full systems approach is needed. When we look at the different components, and again, I have just put here a very basic list. This does not mean this is all that would be there in your system. You may have one or more of these components. You may not have some of these components. Nevertheless, when you look at the steam system and do a steam energy assessment, you have to kind of look at all these individual components, but how they interact at a system level. So in the generation area, everything from boiler, auxiliaries, water treatment, pumping of the feed water, distribution, could be steam piping, pressure reducing stations. End uses can be varied, as we just said, and recovery. Everything is, all these areas is what we will absolutely cover when we do our 3-day training. And more importantly, we'll try and identify ways to make sure that we can kind of evaluate opportunities at all the areas and understand how impacting something in the generation area or changing something in the generation area can impact end use and vice versa. When we get into the generation area, start off at the boilers. Most of you will probably have seen fire tube boilers. Typically have some pressure limitations, have some steam flow limitations. These are classic bread butter for low pressure, for small, medium steam users. And yes, there is an overlap. Generally, they create saturated steam. They are manufactured off-site, so these are the package units, and many different styles are available. Some quick pictures, if you ever had a chance to open and look at them. The tubes, fire tubes, so basically our combustion gases, our flue gas is in the tubes, and you got the main burner tube, which is the radiation section, followed by the convective sections and multi-passes, so on and so forth. The workhorse of the industry, water tube boilers, can have pressures ranging from atmospheric to in excess of 2,500 or even up to 4,000 pounds in power plant side of the story. Steam production range is almost limitless, from a small boiler to an extremely large, up to 10 million pounds per hour. Both saturated, superheated steam can be possible. Most of them will be constructed on site. Yes, there are several places where I have seen packaged configurations which are built off site. A lot of rental boilers sometimes will obviously come on a skid or something of that nature. Many different styles here too. So you could have a large boiler out there, sometimes much smaller units, but generally the workhorse of the industry is a water tube boiler. There are a lot of boiler auxiliaries that go with it, including fans, forced draft, induced draft fans, got combustion air preheaters, feed water economizers. An energy assessment has to take into account all these pieces and how they synchronize and work together to give the highest efficiency that you would want in the generation area. We will absolutely need sensors. We will absolutely have some stuff to kind of ensure our heat transfer is good, be it soot blowers, mainly for solid fuels. Most of you probably may not be having solid fuels, but if you do have coal or heavy fuel oil or any biomass, you probably know what soot blowers are. And then obviously pollution control equipment again. So as I said, every plant is unique. Even though I may have been to so many different industrial facilities all around the world, as Tom said, and that's true. I travel internationally quite a bit doing energy assessments. I've never seen a plant which I can say is identical or exactly the same as something else. Something always is different. Fuel storage, again, something for those who may be handling solid liquid fuels. You'll have to absolutely look at that, worry about that. It could be primary or it could be backup standby. Once we get to the steam side, you got the deaerator. We'll talk a lot about it in the class for sure. We'll evaluate some of the reasons why it's there. But main purpose of it is to kind of remove the dissolved oxygen from the makeup water and condensate and heat the water at the same time. Generally, we'll have a steam vent to kind of remove all the dissolved oxygen and the other inert gases in there. Pumps are something that will take the water, which is now feed water, out of the deaerator, So the boiler feed water pump comes in. There are several additional pumps in a steam system: condensate pumps, makeup water pumps, other auxiliary services, dosing pumps for chemical input, so on and so forth. Water treatment is an integral part of a steam system. It's extremely important, boiler water chemistry, and I know there is a person out there who's really going to actually do a lunch and learn session on water chemistry during the 3 days. But depending on your water quality and operating pressure, you may have several options. At a bare minimum, every steam system will have a softening, but then you might have demin, you may have reverse osmosis, condensate polishing, and so on and so forth, to ensure the integrity and operating life of the boiler. Once steam is produced, we are on to distribution. Transport the steam to the end use. Pipe racks, pressure headers, isolation valves, all of those things come into play. Pressure reducing valves are some of the key things that we will absolutely kind of work with, also known as let-down stations. Why are they there? Are there any benefits towards using back pressure turbines in parallel with pressure reducing valves? That's a classic cogeneration question that gets asked. We try to kind of evaluate that using our 3M plant as a basis. We have steam turbines. Some of you may not deal with these at all. Some of you may be dealing with this all the time. Devices which convert thermal energy into shaft power. Electrical power can be through a generator, or a lot of places you can have a mechanical equipment being driven, a fan, a pump, a compressor, chiller. There are different kinds of steam turbines, and depending on the application, the need, you will actually end up using turbines, or you may not use turbines at all. Heat exchangers is something that almost everyone will use. Very basic kinds of heat exchangers. Their sole purpose is to transfer the heat. Steam basically is the thermal energy transfer medium, and it transfers the heat probably in a heat exchanger, be it a shell and tube, plate frame, tube and tube, spiral, any different configurations. Classic configuration for almost every plant. But in addition, there could be a lot of other end-use equipment that your plants may have. Washing, drying, finishing in textiles, cookers, feed water heaters. As you get into process industries, evaporators, distillation towers using reboilers, reformers, steam jet ejectors, thermocompressors, all those end up becoming steam end-use equipment. And evaluation of all of these things is extremely onerous. It can require a huge amount of understanding of the process industry, which sometimes is not easy. And so you have to kind of cherry pick on some of the largest, some of the more critical, and those that can probably have the biggest impact from a perspective of energy efficiency and optimization. Once steam has done its job, you end up having to remove condensate, and that is done using a steam trap. Steam trap's jobs are obviously several, but the cardinal two are trap the steam and make sure it doesn't leave before it has transferred its energy, and once it's transferred its energy, remove condensate as fast as possible. There are several different kinds of steam traps, and again, the intention of this in-plant training is not to kind of end up making any one of you a steam trap auditor, but to be able to kind of put forth enough of a justification of why we need to have a serious look at a steam trap management program and what could be the benefits, what could be the characteristics of a steam trap management program. So that's basically what we'll be doing. We'll be talking about steam traps. We'll be seeing steam traps in the plant. There are several different kinds, so on and so forth. a lot of places have flash tanks. Flash tanks serve a huge amount of purposes. First and foremost, they are great sources of recovering energy from condensate. High pressure condensate flashing to low pressure steam. A lot of times they also kind of becomes reasons why system reliability gets benefited significantly. You can eliminate a lot of problems of water hammer, back pressure, two-phase flows by having flash tanks. Recovery of energy is key, but ensuring that the system operates reliably is very, very important from a plant perspective. Condensate recovery system, again, can be pumped, primary, secondary, can have electric-driven pumps or steam-driven lift stations. Trying to return the condensate back with the highest thermal energy to the boiler house is the key approach that we look for in evaluating condensate recovery systems. Is condensate being collected? If it is collected, is it being returned with the highest thermal energy possible? Condensate tanks, there could be a main condensate tank, or you could directly end up going into the deaerator depending on the system and its configuration. So I showed you a lot of graphical pictures and photographs and things from the field, but at the end of the day we need to put them all down on a piece of paper, and this is how a system diagram or a one-line flow diagram gets put into place. We got boilers up here. They get feed water, they create high pressure, high temperature steam, probably goes on the high pressure header, then into some heat exchangers or users at the high pressure level, or through a pressure reducing valve to a medium pressure header. There are these devices which are known as turbines. They can either drive a mechanical equipment or generate power. On the medium pressure header, you can also have heat exchangers. You can take high pressure condensate and flash it in this flash tank to create medium pressure steam. If steam is not required on the medium pressure header, it goes through a pressure reducing valve onto the low pressure header. Or it could go through the devices known as turbines. Back pressure turbines generally will have steam from a high pressure exhausting to a lower pressure. On the lowest pressure level, you got steam users from processes, heat exchangers, hot water heating, even steam being supplied to the deaerator can happen from the lowest header pressure. And makeup water is basically what is required to complete the mass balance of the water steam side. Any condensate that is not recovered is to be made up by makeup water. Any other losses that happen on the steam side are made up by makeup water. All that ends up into a common tank. From there it's pumped into the deaerator, boiler, feed water pump, sends it and completes the loop. So that's kind of like what we'll try and make sure that we understand. This is the high level. Let's understand what the plant is about before diving deep into a particular heat exchanger or a particular component. Understanding from a high level what the system is all about is where we begin. So what's our objective? Well, obviously minimize steam usage, minimize energy losses, reduce greenhouse gas emissions, but most importantly, reduce the operating steam cost. There are several energy assessments and market takeaways that have been there and done by the DOE. DOE kind of has compiled a lot of these results. We have seen individual projects that have ranged from 0.5% to about 5% savings. We have seen projects generally with very good payback periods, mostly ranging from 2 to 34 months, generally most of them less than 2 years. But that does not mean you should ignore projects which are very good and may have a slightly longer term for payback. It may be your internal rate of return that may dictate what you will do and what you will keep in the hopper. Overall, there have been savings in the range from around 10 to 12% or so. I'm not saying again that this is what we will find in the Cordova plant. I have seen some of the numbers that they have provided me with, and I think it's a good plan to start with. Let's see what we can do there. But overall, they seem to be doing a lot of best practices, and from the information that they have provided to me, it seems that they are an above average plan to begin with. So it will be something that we will kind of have fun during those 3 days in a week and a half. So where do we begin? The first tool that we talk about is the STEAM system scoping tool. As the name implies, scoping. It is scoping the STEAM system for initial assessment. And the way it is designed, it is built in a manner where there are qualitative questions which are answered. You can have this tool available to the plant and fill it up, or you can be doing it yourself as you do an assessment of the plant. Most of the times it's best to have this information before you start your assessment, because the purpose of this tool is to scope the STEAM system and be able to identify the red flags and the major areas that you may want to focus where best practices are missing. So in some ways, it's doing a gap analysis for you to help you sharpen your focus when you start your assessment. It is organized as different worksheets. There are, as I said, these are qualitative questions. There are 26 qualitative questions, each targeting a specific energy conservation measure. The questions that you answer yes, or you say you do that best practice, obviously means that you've already captured that low-hanging fruit and you're already on the road for best practices. Places where you have answered no or have scored less points on this questionnaire are the areas where you may say, let's go and investigate those areas in this plant first before getting into details into a lot of other things. So it's available in an Excel spreadsheet format. It's available as a Visual Basic format. Being the nerd engineer that I am, I love Excel, and that's kind of like what you are stuck with. So you'll probably use Excel during the 3-day training, but there is a Visual Basic version. It's got radio buttons, automatic entries, and things like that. I like the Excel version for several reasons, and I'll kind of talk about them when we get into our 3-day plant course. A very quick look at what the tool looks like. As I said, it's 26 questions divided into 4 sections. There is the STEAM system profiling section as the first. You got to monitor and meter before you can manage. You have no idea what you're controlling it at if you do not have the ability to know where you are. And this is what that section focuses on. What I have also provided you is kind of some idea of what an average industrial steam plant scores. So the way this works is it works as questions. The first question is, do you measure your fuel cost to generate steam? If you do measure your fuel cost to generate steam, you would get a maximum of 10 points. And if you don't, you get a 0. So if you see a score of 7.4, again, that's a cumulative average of several industrial plants that we have collected information from, and it shows that about 75% of the people do this. And as you go down the list, you can get an idea of what the scores are and what the profiling section ends up. So one way to do this is to do it for your plant and compare it to what an average score looks like in the industry. This is the first section of the tool. The second section has to do with steam system operating practices. You are being quizzed on steam trap maintenance program. What are the characteristics of that program? Your water treatment, insulation, leaks, any issues with water hammer, and an overall effective steam system maintenance capability. That's steam system operating practices. Then we will talk about boiler plant operating practices. And again, these are qualitative questions. Nowhere will you be asked about what is your boiler efficiency, but more importantly, do you measure boiler efficiency and how often do you do it? What do you measure? Flue gas temperature, oxygen percent, so on and so forth. Do you have heat recovery equipment? All that kind of good stuff. So once you go through this, then you get to the last section, which is a very small one on distribution, end use, and recovery, to an overall average of what your plant scored in all these 4 sections. So again, the way to use this tool, relatively quick. Before you start an assessment, it identifies the gaps. Places where you have scored low are the areas of interest. Places where you have scored high are things where you're already doing best practices and you're already where a state-of-the-art best practice plant should be. So identify gaps. Completing this tool should not take you more than half an hour to 40 minutes. It's just what it's meant for, identification of potential areas. It scopes the system, identifies potential areas. It does not quantify the opportunity. It is not a quantitative tool. It's only for qualitative identification. Are there any questions up to this point? I have not seen anything in the chat box, so I will continue on. The next tool that we are going to talk about is the STEAM system assessment tool, and this is an absolutely quantitative tool. This is something that produces a mass, energy, and an economic balance for your STEAM system. It absolutely is meant to evaluate opportunities. It completes a thermodynamic model of your STEAM system based on the inputs you will provide, and then it does what-if analysis to kind of help you understand what opportunity could be there, and if you implemented a project on that opportunity, what potential savings could be achieved in your system. So it's a thermodynamic model that does mass, energy, and an economic balance. It will require Excel, and for those of you who are attending this training, I would very much want you to possibly come prepared for installing this software on your computer. That will require admin privileges on your machine. So if you have an issue with that, maybe the thing to do it is to have it pre-installed with your network administrator and or IT person, so that you do not have an issue when you come to the 3-day training. If you have any concerns or any issues about the software, I think you're more than welcome to email me. I think somewhere in the beginning of the presentation I had my email. I'll flash it up again at the end. But the idea is that this is the model that we will use. I will give you another option in case we, as another tool which has been developed, and we'll talk about it here shortly. But SSAT is kind of the main tool that we will kind of use. Again, has the ability of different pressure modeling, in the sense you can do a very large complex petrochemical plant model or a pulp and paper mill model here, or you could kind of model a very simple heating application that happens, let's say, in a cooking plant, in a food and beverage facility or something like that. It simulates all the major equipment that we have touched upon in a STEAM system. Once it's done that and built a model, it can evaluate STEAM system improvement projects, and a lot of times we will evaluate them projects as one at a time. What would be the impact if I put in a heat recovery system on the boiler, and that would be one project. But a lot of times you may want to evaluate multiple projects at the same time to see if there is any combinatorial effect, or if one project overlaps with another and you don't want to double count when you evaluate single projects. So it's a very, very powerful tool, allowing you a lot of flexibility, and I've been using this for a long time. It is actually a tool which basically uses a commercial engine called ProSteam, and there were entities. The U.S. Department of Energy has got a universal site license to distribute this engine at no cost, so it's free to you. There have been several people who have worked to make this tool happen, including Spirex Arco, Dr. Greg Harrell, and the Steam's Best Practices Technical Committee of the DOE to kind of put this tool in place. It's very, very powerful, very effective to be used in an assessment. It's in Excel, so you've got worksheets, input, and I'll show you some of the graphics here shortly. There's an input page, a model page. You can input projects and see what if evaluations can be done. It will show you what the new system will look like in the project's model. Results is where the rubber meets the road. And that's the key page that you will always refer to when you're doing what if analysis. Additionally, there are some good tools in there, including a stack loss calculator. So calculating boiler efficiency using stack loss information. And last but not the least, a user calculation page which can store a lot of data that you may collect during the assessment. So everything is captured in one file, raw data, model, as well as the results. When you open it up, it will kind of take you to the input page. Again, being in Excel, straightforward stuff. There are several cells which are locked that you will not be able to change. Everything that is yellow is where inputs are needed. Every other place is locked. So it's not something that you can kind of, overrun or something like that. So very, very robust and reliable model. Once you have provided the input, it generates a base model line diagram. And as you can see, you got boiler, you got a high pressure header, you got a low pressure header, you got pressure reducing valve, you got a back pressure turbine, a condensing turbine. For those of you who are chemical engineers will recognize this symbol as classic for users, or a heat exchanger that takes the steam, makes condensate, steam traps, flash tank, condensate being returned to the condensate tank, users on the low pressure, its condensate, all combining. The deaerator model is all inbuilt, takes steam from the low pressure header, does the water balance. Anything which is missing comes up from makeup water, blow down evaluation, calculations of flash tank, heat exchangers, so on and so forth. Once you have built that model, you're satisfied with it, you can go into the projects and say, oh, I saw certain areas that I want to evaluate and do projects on. So turn them on, you do these projects, and you come up with results. Results generally represented as numbers, the current operation, which is the base case, followed by after projects, the changes that you made. How much savings would be given in green, anything red means an increase. In this case, probably it was a turbine project which showed power can be saved, and we will need some more fuel for steam, extra steam, and we'll need some more for makeup water. But there are also emission information in here, and I'll talk about that when I get into the class. Depending on the fuel you use and things of that nature. For natural gas, these are very solid numbers for emissions and can absolutely be used. If you get into different fuels, you might have some questions. So very solid results, and as I said, the stack loss calculator, allowing you, this stack loss calculator can be used for boilers or even for process heating, where you have the information regarding what is the stack temperature and what is the ambient temperature and the oxygen content. There is one more thing which I wanted to kind of touch upon, and identical to SSAT. SSAT is in Excel, has to be installed and all that, but there is a web-based version which is known as the Steam System Modeler tool that has been developed by the DOE. It is online, it is on the DOE website, and I know the website is really dangerous the way it looks like. I would say the best thing for you to do is an internet search on US DOE Steam System Modeler, and it will take you right there. This exactly does everything that SSAT does, with some small differences. Firstly, it's online. I also like it because it can do much more detailed individual component modeling. SSAT can do the same thing, and it's all one-to-one. One of the pluses here in this is the schematics of SSAT are static, whereas here the schematics are dynamic. And again, a little bit difficult for me to explain. I probably will do that when I guess I get into the 3-day class. But this is where you would end up. This is the Steam System Modeler page on the DOE website, and you can run it right there. You can save the data also in an Excel file, but it was not something which is directly compatible with SSAT. It has its own format of an Excel file. SSAT has its own format of an Excel file. But you can do whatever you do in SSAT in the Steam System Modeler. It will give you, as I said, schematics of the system. The nice part about it is, in the event, let's say when I said the schematics are dynamic, which means if you don't have certain components, it will not show up on the schematics. Whereas in the SSAT, they will show up with 0 values, meaning nothing much is happening, or that component doesn't exist. And it will also, like SSAT, give you cost summaries and marginal steam costs and stuff like that. So identical stuff. Those of you who feel that you want to use the online version, feel free to do so. Those of you who want to use SSAT, feel free to do so. They both do the same thing, and we should have the same numbers. So, but both of these are the heart of the energy assessment. These are tools we'll spend a lot of time in when we evaluate projects. These are the tools that we will use to evaluate almost every project that we come up with during our assessment. I want to shift gears a little bit and talk about one last tool, which is dealing with insulation. Insulation, from my perspective, is foremost from a safety consideration. It comes first and mustn't be compromised. There may be OSHA requirements or your plant requirements for surface temperatures. That's all in there. Yes, there is an energy cost reduction. No doubt about that. There are also production benefits. There's also another separate certification program on insulation appraisal. It's not something that DOE offers. The National Insulation Association offers that. If someone's interested, you can go down there. Our purpose will be to kind of look at this insulation from an energy opportunity, from a safety perspective, if that comes into play. Just a quick example, a 200-pound, 400 Fahrenheit steam system, 10 feet uninsulated line, 8-inch pipe, very classic header configuration. Could be losing about 300 million BTUs per year, year-round operation. And that could be almost, at our prices of about $5 a million BTU nowadays, 80% boiler efficiency, could be looking at almost $1,800 to $2,000 a year of just energy cost. Not sure what it does to the process or production side, but that's kind of why we are interested in. We are interested in it from an economic perspective. So we are going to use the 3E Plus insulation software. It's developed by the North American Insulation Manufacturers Association, NIMA, and it is used as one of the software tools in the best practices Steam Tool Suite. It's an amazing software. Actually, I've used 3E Plus almost during the Windows DOS days, and some of you don't probably know what DOS stands for, but the good old disk operating system. It used to come on these 5 1/4 inch discs, so it's an extremely powerful software. But as newer insulation material has come about, they have obviously updated it, and nowadays you will see it being used in a classic Windows-based configuration. Its ability to do heat transfer calculations, as far as calculating paybacks and return on investments with a life cycle cost on insulation projects, is how detailed it can get into. Our objective is still to kind of remain at a heat transfer level, an energy loss perspective, but it's got some very quick tools in there. So 3E standing for energy, environment, and economics. That's what insulation impacts very clearly, and this is kind of the software that you will install and you will use. I don't think this software installation needs admin privileges, but depending on your security levels, you may want to make sure that you install this, if you're doing the SS80 installation at the same time. You will need information. You will need process-based information, ambient temperature information, pipe sizes, or, it can even do ducts. It can even do flat surfaces. It can do all different configurations. And although I'm talking here with a steam approach, this software can also be used for refrigeration, chiller systems, condensation control, and stuff like that. But you will need information about the base metal, about the insulation material. This is another place where it's very powerful, because being built by the manufacturers of insulation material, it's got all the thermal properties, conductivity, resistances, so on and so forth, temperature dependence of a lot of insulation materials. And you can just use that database, and you don't have to go running around to see what insulation properties your insulation has. And once you kind of provide that information, provide what you want to try and do, it will spit out a table which will help you to understand what does the bare pipe or surface do versus as you insulate it with different thicknesses, what kind of energy you can save compared to the bare surface that you have. So again, something we will get into detail, and we'll surely use it in our assessment. More than welcome if they have any questions. I'll be more than happy to answer them right now or during our 3-day this. And again, it absolutely takes into account cost, and it can give you the cost benefit for insulating bare surfaces. So at the end of the day, as I said, it kind of does a life cycle cost calculation. If you want to get into it, it's over and beyond the scope of what we will be attempting, but the tool is absolutely built to identify the minimum insulation or the optimum insulation thickness to ensure the lowest operating cost for the life of the insulation. I kind of have to take back this slide partly because I don't think some of the tools are up there. The SS modeler tool is absolutely up there, and you can use that and Google it, or use an internet search engine to search and get to the software. There is some additional help which is available again on SS80. There is a survey guide which is authored by Dr. Greg Harrell. It's a good resource. All these are available online from the DOE site, and you can get to them. The source book, an industry thing that you may want to leave on your table, but given the contacts and resources which people have nowadays online, this is not something that you would be your first choice, but it still exists, and it's a good thing for steam system basics and performance improvement opportunities to be looked into. There are energy tip sheets available, one-pagers which talk about an issue, give you an idea of what you can look into, and probably some resources to follow up. So I think I've just pushed my time a little bit more than what I wanted to do, but again, my intent was to give you a high-level idea of the tools, best practices, and general overview of STEAM systems. I hope I have done that. I would like to leave you here with like a basic summary. We talked about the scoping tool. It's kind of a gap analysis, qualitative assessment, identifies areas. Then we jump into the STEAM system assessment tool or the modeler to model the STEAM system, complete the mass, energy, emissions, economics balance before and after the projects, very quickly be able to quantify the economic impact of one or more projects. We talked about 3+, again, very briefly, but it's got a lot of capabilities. And again, as I said, if someone wants more information, probably NIA is the place to research. That's about all I had. And again, I'm looking at my chat box. I don't have anything in it. Tom, I'm going to turn it over to you. This was the last slide on my presentation. If someone does want to reach me, probably the best way would be via email. I end up traveling quite a bit, and I think my phone is pretty much a useless thing. I do have my cell phone with me, but most of the time if I'm in a plant or something, it's off. So best way probably to reach me is via email, rpapar@hudsontech.com. And I think I wanted to stay within the time, which I hope I have been at. So I would like to turn it over to you folks, Tom, and C or Deb at 3M in case there are some things we want to talk about for the 3-day, or if there are any questions.
All right. So Riyaz, thank you very much. I think that was really informative. I always learn something when you're talking. Maybe, hopefully it's not because I'm so dense, you know. I thought that was really good, though. So I wanted to flash the agenda once more. And for individuals coming to the implant training, and especially for those that are coming from other 3M plants or other, you know, outside organizations, I would, and Riyaz, you know, he echoed it during this presentation, I would plan on bringing some system information for your own system to this training. We're going to put you to work during the implant training, so we're going to be learning from Riyaz, but we're also going to be working. So we're going to work through the models and learn how to look at these systems, analyze them, and model them. And as has been shown in many of these past implant trainings, if you bring information about your own STEAM system, we'll have an opportunity to model your own systems, and in some cases we've been able to identify opportunities that that you can think of that are real, and have an opportunity to sit and work with Riyaz or others to model those opportunities and try to quantify some of the things. So Riyaz mentioned the STEAM scoping tool as well as the STEAM assessment tool and the STEAM modeling tool. If you take a quick look at any of those and bring some of the basic information to the implant training, I think you'll find it beneficial and you have a leg up. So with that, I don't see any further questions. I'm going to give it another minute or two. If people on the line, if you have questions, raise your hand or type them into the chat box. But right now I'm not seeing anything, so I don't know if we're going to receive anything. But again, flashing up the agenda for the event. And if there are folks that are listening in that are interested in attending, please contact me or someone else on the 3M team, and we'd be happy to try to fit you in and get you a spot. It should be a really good event. All right, so I'm not seeing any other questions or hands raised. So I think we can call it a day. And for those of you that will be at the implant training, I'm looking forward to meeting you and working with you. Riyaz, again, thank you for the excellent webinar today. I think it was really useful.
Thank you very much, sir. Thanks very much for attending. And I look forward to seeing several of you in Cordova. Thank you.
All right. Take care, everyone. Bye-bye.